Hi, welcome back. So we're going to discuss the method by which Geoffrey Taylor did his almost magical derivation. In order to do this, we need to identify the variables. And those are in our case E, which is energy, R, which is the radius of the shock wave, T, which is time, because it's a time dependent process. And we're going to say that maybe intuitively we can't think of anything else. We'll see if this works. Okay. So we have to, in a way, define the problem. Why we are solving it. We want the energy. And eventually we will want to put units, which means we'll need real values. Okay. So the next step is to say that we define relations or we connect the variables. So interrelate the variables. In order to do that, we're going to note that we intuitively think the radius of the fireball is proportional to the energy. It increases with time. We observed that already. And it could have something to do with the medium in which it is happening. In this case, it is air. So we will take the density of air. The third step we take is dimensional analysis. Now, this is a very important step. Those of you who remember your high school physics remember mass, length, time. As the fundamental dimensions. R, therefore, in terms of dimensions, is given as L to the power 1. Energy is force into displacement, which is mass into acceleration into displacement, which means m1. Acceleration is length per unit squared time, and distance is length. So you have L to the power 2 and T to the power minus 2. Density, it's mass per unit volume. So m1, L minus 3, T 0. So the fourth step is to equate proportionalities. And so we say that R is equal to e to the power x, rho to the power y, and t to the power z, where x, y, z are all unknowns. We want to find them out. The most exciting step here is to use the dimensions to give us a sense of what these numbers are, these values of the unknowns. So for the right hand side, we say it is E, which was m L squared t minus 2, m L squared t minus 2 to the power x, into rho, which is ml minus 3 t0 to the power y, into m0 x0 t1 to the power z. But LHS, the left hand side, is r, which is equal to L to the power 1, which means m0 t0. This means that when we equate LHS and RHS, it must satisfy a series of simultaneous equations. These are x plus y is equal to 0. This is for m. For L, it is 2x plus minus 3y is equal to 1. And for time, it is minus 2x plus z is equal to 0. These are our three simultaneous equations in terms of x, y, and z. And now our job is to solve them. The way we solve them is that we can simplify this equation with x written from 3 as x is equal to from 1 x is equal to minus y. Substituting in 4 in 2, we get 2 minus 2y minus 3y is equal to 1, minus 2 plus minus 2 minus 3 is minus 5y is equal to 1. Therefore, y is equal to minus 1 by 5. This is our first solution. Now we can substitute this back into 1 and write down x minus 1 by 5 is equal to 0. Therefore, x is equal to plus 1 by 5. This is our second solution. And now we substitute 6 in the last equation, which is the only term with z. 3, we get minus 2x plus z is equal to 0. That is minus 2x is 1 by 5 plus z is equal to 0. Therefore, z is equal to plus 2 by 5. Remember, these are exponents, which means substituting 5, 6, 7, 5, 6, and 7 in this equation should give us now a solution. So we get to write r is equal to e to the power x, which is 1/5, into rho to the power y, which is minus 1 by 5. You see a pattern here, into t to the power 2 by 5. This means that we can now get r in terms of e rho t, rearranging, because remember, we want to know the energy yield, the secret of the United States at the time in 1945, before our independence. We get 1 by e to the power 1 by 5 is equal to rho minus 1 by 5 t 2 by 5 upon r. Inverting, we get e 1 by 5 is equal to r upon e to the power minus 1 by 5 into t 2 by 5, which means we can write it as rho to the power 1 by 5 upon t to the power 2 by 5 into r. We take power 5 on both sides. We end up as e to the power 5 is equal to rho to the power 1 by 5 upon t to the power 2 by 5 into r whole to the power 5, and it resolves to e, 5 and 5 cancels here on the left hand side, to the power r to the power 5 rho upon t square. Now, this was missing a proportionality constant, and this the investigators estimated. From the data. This was how the deep mystery was solved. Isn't that exciting?